check your answers with mine and let me know what questions you have. So if you weren't trying these, that doesn't help you if you just copy down the answers. Make sure you're actually practicing these. So number 1, the final answer should have been 10 times the square root of 7 plus 2 times the square root of 2. That could not be simplified anymore. The radicands are not the same. Questions on number 1. If you flip the order so that it was 2 times the square root of 2 plus 10 times the square root of 7, that is also fine. Number 2, we didn't do examples where we're multiplying cube roots, but it's the same thing as square roots. We would multiply the insides together, multiply the outsides together. We didn't have outsides here, but when you multiply the insides, we get 432. And then we would need to simplify. So the highest perfect square that goes into 432 is 216. Perfect cube is what I meant to say. And then the cube root of 216 is 6. And the cube root of 2 cannot be simplified. So 6 times the cube root of 2 would be our simplified final answer. What questions do we have on that one? Number 3, we were adding these two expressions together, but we had to simplify them both. So if you simplify the first one, we get 2 times the square root of 2 times x times the square root of x, and then times the 5 that was outside. Simplifying the second part, we have 3 times the square root of 2 times x times the square root of x, times the 3 that was on the outside. And then we could start to bring those all together. So I multiplied 5 and 2 and 3 and 3, and then started to rearrange. So on the outside for the first one, we have 10x. On the inside for the first one, we have 2x. On the outside of the second one, we have 9x. And on the inside of the second one, we have 2x. So now we have the same radicand for both. So we can add them together. We also have variables on the outside that are the same, so we can add those together. So 10x plus 9x would be 19x times the square root of 2x. What questions do we have on that one? For the last one, you need to find the area, so that's length times width. So multiply these two together, 3 times the square root of 6 and 4 times the square root of 15. Remember, your insides get multiplied together, your outsides get multiplied together. So 3 times 4 on the outside, 6 times 15 on the inside. So we have 12 times the square root of 90, which can be simplified. The highest perfect square that goes into 90 is 9 and 10. So 3 times the square root of 10 multiplied to 12 would give us 36 times the square root of 10. What questions do we have on that? Barrett?
Why does the short long chance to a 36?
Because we're multiplying 12.
Oh.
Before we go over some review problems, we're going to finish off the last bit of radical operations. So take those notes out if you haven't already. We basically covered everything in those notes except for the last part of the multiplying, which is what happens when we have to distribute. So we're going to do a few of these examples, and then we'll go over some examples on the review. Then you'll have time to practice all the problems from this that we didn't, or whichever ones you feel like you need to practice, as well as the review problems. So starting with example 1. If this were something regular that we were distributing, we would just multiply what's on the outside to everything inside. Same thing. We just also have to remember all of our radical operations. So we're going to take this and multiply it to both of these things. When we do that, if they both have a radical, then I can put them both underneath the radical and start to simplify. If they both don't, so here I'm multiplying 3 and the square root of 6, that's just going to become 3 times the square root of 6. I'm not going to actually multiply 3 and 6 together. And then I'm going to multiply 6 and 8, but those are going to be both underneath the square root. So we have 3 times the square root of 6 plus the square root of 48. Now I can simplify the square root of 48. What is the highest perfect square we can divide out of 48? 16 and 3. The square root of 16 is 4. And I'm going to bring this other one down. Can we do anything else with this?
Got 2.
No. 6 will not be simplified anymore because 3 and 2 is not a pair. 3 cannot be simplified anymore, and we cannot add these together. So this is it. Now, this second part we haven't talked about yet, and we're going to in the next unit. So if memory serves me correctly, you won't see anything like this on the test. But it is good practice for the distributing. If you see something like this where there's 2, you're going to distribute twice. So take it step at a time. Doesn't matter really which one you choose first, but I always go with the first one. And we're going to multiply that to everything in the second set of parentheses. So I'm just going to worry about that part first. We'll deal with the other part here in a second. So 4 times, basically we're doing this. Say that one more time.
Why do we have to?
We have to multiply both to both, and this is the only way to really do that. So if we're multiplying this to both of these, this would become 8 minus 4 times the square root of 3. We also have to take that other number we had in our parentheses and multiply them to the same thing we just did, to the second set. So we can think about it like this. We're taking this second term, that should be the square root, and we're again multiplying it to this. So if you want to rewrite it like that so it makes more sense, do that. Yeah. 8, and then 4 times negative 3 is negative 4. So then multiplying these two, we have plus 2 times the square root of 3 plus, I'm sorry, this would be minus 3 times 3 underneath the square root. So then we can start to simplify a little bit. Before I simplify these, I'm going to go ahead and deal with this. We have 8 minus 4 times the square root of 3 plus 2 times the square root of 3 minus the square root of 9. The square root of 9 can be simplified to just 3. So we can combine our integers together and our square roots together. 8 minus 3 would give us 5. And then negative 4 times the square root of 3 plus 2 times the square root of 3 would be negative 2 times the square root of 3. We're going to check this in our calculator, but before we do that, what questions do we have on this? Eric.
So is that the final answer there?
The 5 minus 2 times the square root of 3.
So you subtract the 2 on either side.
And you could rearrange this, so if you wanted to, you could put 8 minus 3 minus 4 times the square root of 3 plus 2 times the square root of 3. That way you know which terms go together. Yeah.
It says plus 2.
But this was negative. Okay, so before we do anything else, let's put this in our calculator. So in parentheses, we had 4 minus, I already forgot what this was. No, minus, what's it plus?
4
Plus, thank you.
the square root of 3. And then 2 minus the square root.
Because we're multiplying, we can't just add them together as is. If we weren't multiplying, then we could. But then our final answer, we got 5 minus 2 times the square root of 3.
Oh my god.
So that worked. What other questions do we have on that before we continue? For these, I would take it one step at a time for all of them. So let's jump to number 13. For number 13, we're doing the same process. We have this one number that we have to distribute, but we're distributing it twice. Take it one step at a time, do what's on the outside, multiply those together, and then multiply what's on the inside together. So negative 2 times 3 times the square root of 3 times 10. If you want to just focus on that one and then do the next one, you can do that. Or if you want to write them both down at the same time, that's also fine. So this would be, it would end up being plus negative 2 times negative 3. I'm just going to write that as 2 times 3. Because the negatives would become a plus. If there was still a negative, then I would just put minus.
So within it is 6, or you just rewriting it?
I'm just rewriting it. And then 3 times 6. So simplifying all of this, we would have negative 6 times the square root of 30 plus 6 times the square root of 18. Can we divide 30 by a perfect square? No. So that's going to stay the same. Can we divide 18 by a perfect square?
Yes, 9.
Yes, 9. have negative 6 times the square root of 30 plus 6 times 3 times the square root of 2. So negative 6 times the square root of 30 plus 18 times the square root of 2. You cannot combine that anymore, but that would be our final answer. Questions on that one? Now let's jump down to 17 and 18, where we are now distributing twice. For 17, again, if it helps you to rewrite, do that. We're going to take that first term and multiply it to everything in the second set of parentheses. So I'm going to rewrite that as 6 times the square root of 3, and then in parentheses, 5 times the square root of 3 minus 4. Just so it looks a little bit simpler. Then I'm going to take the second part of this and do minus 2 times that same inside. 5 times the square root of 3 minus 4. And then we're going to go ahead and start distributing. If I'm multiplying these first two together, on the outside we would have 6 times 5. On the inside we have 3 times 3. For the second set, we have minus 6 times 4 times the square root of 3. And then I'm just going to keep adding down the line. So if we're multiplying negative 2 to these two, we have negative 2 times 5 times the square root of 3. These are going to become a positive, so plus 2 times 4. And then we can start simplifying. So going down the line, we have 30 times the square root of 9 minus 24 times the square root of 3 minus 10 times the square root of 3 plus 8. If you want to, like you see that these are like terms, you want to go ahead and combine them, you can do that now. You can wait till the end. That part doesn't really matter as to when. Square root of 9 can be broken down to 3. And we can combine these two. So I'm going to go ahead and do that in the same step. Or you could wait till the end, it does not matter. So negative 24 minus 10 would be negative 34 times the square root of 3.
Plus 34. They're both negatives.
You're not multiplying. And then plus 8. 30 times 3 would give us 90. And then we could combine our 90 and 8. 98 minus 34 times the square root of 3. With these distributing problems, I would definitely recommend that you check it in your calculator to make sure that all of your numbers are right or that your decimals match. Before we do this last one, what questions do we have on this one?
times, like, there's a number we multiply, number times a radical. Would only multiply that number by what's outside.
So that makes sense. Say that one more time.
So when you have, let's just say, 5 parentheses 2 over, or 2, 3, sure, 3 plus 1. When you multiply 5 by a radical, would you just do the one outside?
Yes, so you would just be multiplying 5 and 2, the radical would just become next to it.
Okay.
Any other questions on that?
Is that 1/3 next to the 30? It's like 30 times 1/3. Or
This is just 3.
okay, so the line above the 3.
Oh. This was saying this square root of 9 is 3.
Okay.
Aubrey.
What would happen if we have variables?
Say that one more time. What would happen if what?
If we have variables in there?
I'm gonna say that it's not going to do that, but let me do that.
Stop. No.
Like this last one. That one would have radicals or variables. I'm gonna say 1. Let me double check this, but I don't think the distributing with the 2 is even gonna be on there. If it had variables, it would go back to like the multiplying radicals with variables, and you would just do that. But while I'm thinking about this, let me check this right now. No. Yeah, so you won't need to worry about that. But it would be similar to when you were multiplying. Last one we're going to do on this is 18. So if you see something like this, you should know that this is the same thing as 2 times the square root of 7 plus 1 times 2 times the square root of 7 plus 1. Which means we would do it the exact same way we just did 17. What you should not do if you were to get something like this is take the square of this and this separately, because you'll get something different. After this, we'll switch gears. Alright. So let's start this off. The first term times everything in the second. That's not straight. Anyway. 2 times the square root of 7 times 2 times the square root of 7 plus 1. And then 1 times 2 times the square root of 7. I'm running out of space here. And then we can start distributing. We have 2 times 2. Underneath we have 7 times 7 plus 2 times 1 times the square root of 7. And again, I'm just writing it all out. If you would rather just go ahead and start simplifying, that's fine. plus 2 times 1 times the square root of 7 plus 1 times 1. And then you can start multiplying everything out. So 2 times 2 will give us 4. 7 times 7 will give us 49. 2 times 1 will give us 2. 2 times 1 will give us 2. And 1 times 1 will give us 1. It is a lot. Square root of 49 would be 7. Four times 7 would give us 28. And then combine all of your like terms. You have 28 and 1. And 4 times the square root of 7. If you got a review last class, raise your hand. Let's see. So we're going to go through some of these. You'll have only 2 objectives on this. Simplifying radicals, so that'll be with square roots, cube roots, and variables. And then radical operations, adding, subtracting, multiplying. I would recommend that when you get to the test, whether it's the first or the second, you list out as many perfect squares and perfect cubes as possible. That way you don't have to keep remembering what they all are. So really quickly, let's do that. I'm just going to list, let's say up to 15. You can stop at 12, at 10, it doesn't matter. If you want to go to 20, that's fine, because there really shouldn't be more than 20. These ones, I never know by heart. More than that, I don't know.
I tried memorizing it last year, and I like got it to 17 or something.
Or the squares of the cube.
Oh,
Nice.
I forgot them all already.
Like, I know 17 perfect square is 289. That sounded wrong when I said it. I know it's something like that.
Wait, cube for 11 is 151.
Is what?
151.
That does sound right, yes. Yeah. So number 3. So this would be a square root with variables. Is 108 a perfect square?
No.
So what, and with this, remember, you could go back to finding all the factors and doing it that way, or you could do it the shorter way. It does not matter. I'm just going to do it the shorter way so that way you have time to practice at the end of class. What is the highest perfect square we can divide out of 108? 9. 9 and 1.
Oh, 12.
I'm going to say 9 is not the highest because 12 can be broken down to a 4. Double check it.
For which one?
For number 3.
36.
36. 3.
36 and what?
3.
Square root of 36 is what?
6.
We have 6 times the square root of 3, and we're going to bring down this 2. And then 2 goes into 9 how many times? 4. With how many left over? 1. 2 goes into 2 how many times? 1. With nothing left over. And 2 goes into 14 how many times? 7. With nothing left over. So then on the outside, we would have 2, I'm just going to rewrite it right now. 2 times 6 times x to the 4th times y times z to the 7th. And on the inside, the square root of 3. And x. So our final answer would be what?
12 x to the 4.
X to the 4th.
Z to the 7th.
Y, z to the 7th.
I'm sorry, square root.
Square root of 3x. So I take the harder of the simplifying ones. So if you can do that, then you're good. Let's do number 5 and then we'll do 6. For number 5, so this one isn't as hard, but it has a negative, and I wanted to remind you of how to do that. Bring your negative out so that you don't have to worry about it. Is 16 a perfect cube?
No.
No. What is the highest perfect cube we can divide 16 by? 8. 8 and 2. The cube root of 8 is what? And then 3 goes into 4 how many times?
4.
Once. With 1 left over. So on the outside we would have negative 2 times a On the inside, we would have the cube root of 2 times a. So our final answer would be negative 2a times the cube root of 2a. Questions on that one? Number 6 is 320 a perfect cube.
No.
No. What is the highest perfect cube we can divide out of 320? 64 and what? 64 and 5. Cube root of 64 is what? 4. And then 3 goes into 15 how many times? 5. With nothing left over. 3 goes into 7 how many times? 2. With 1 left over. So on the outside, we would have 4 times n to the 5th times n squared. On the inside, we have the cube root of 5 and n. Really, we just need to simplify that or leave it as is, either or. I like it with less dots, me personally, writing it out, but if you left it like that, that's fine. Let's jump down to number 13. I'm sorry, number 10. We will do 13, but let's do 10 first.
Did we finish the?
Mm-hmm. There was nothing else to really simplify. Okay, so we are now adding and subtracting, so this is the second objective. We need to simplify as much as possible. Is 125 a perfect square? No. There's a lot of hesitation there. What is the highest perfect square we can divide 125 by? 5 and 5. And the square root of 25 is what? 5. I'm going to bring down the 7. And all this. Is 45 a perfect square? No. What is the highest perfect square we can divide out of 45? 9 and 5. Square root of 9 is what? 3. And we're going to bring down this negative 2. As we start to simplify all of this, we have 3 times the square root of 5 plus 35 times the square root of 5 minus 6 times the square root of 5. Can we simplify this anymore? Yes. How so?
By combining them.
And what are the like terms?
The square root of 5. Like, yeah.
All of them. 3 plus 35 would be 38. 38 minus 6 would be 32. So 32 times the square root of 5 would be our final answer. Yes. 35. We multiply the 7 and the 5. Let's do 13 on this page, and then we'll jump to the next one. So now we are multiplying radicals. So multiply the insides together and the outsides together. We have nothing on the outside, so on the inside we can multiply these two together. I would say do your numbers first if it's easier, and then worry about your variables. 5 times 8 gives us 40. If we have x squared and x to the third, we combine them. You're adding your exponents. How many x's would you have? 5. Now we can simplify. Is 40 a perfect square? No. What is the highest perfect square we can that goes into 40? 8 and 5? 9. 8 and 5 is right. Oh, because that'd be 45. But 8's not a perfect square. That's why. Yeah.
Sorry.
So if you're doing the factors, if you're doing the factors, 8 and 5 would work, and you just break it up. Now we're all on the same page. And the square root of 4 is 2. 2 goes into 5 how many times? 2. There's one left over. So on the outside we would have 2 and x squared. On the inside we would have 10 and x. So you can leave it like that, or you can write it without all the dots. Yeah, so you have to simplify each piece in it, so even though they're next to each other, they're still being multiplied together. So we still have to simplify it. We are going to jump to number 11. So not this page, but the page after that. I also think I'm missing things on this. That's okay. We'll do these two, and then I don't know where I got those math problems, but I'll just write it. It's fine. Okay, so number 11, we're going to distribute. Square root of 3 times 4 would just be 4 times the square root of 3. The square root of 3 times the square root of 15. Multiply those both underneath the square root. So 45. And we could simplify this. So 2 are 9 and 5. Square root of 9 is 3. Can we simplify this more? Yes. We can combine them. And our final answer would be here.
It's not supposed to be 4 and 5, it's supposed to be 4 and 3.
Sorry,
4 square root of 3, not 4 square root of 5.
this right here.
No,
The 4 square root of 3, you put it as 4 square root of 5. You just wrote it. You replaced the bottom.
At the bottom. This should be a 3. Thank you. Okay. So we cannot combine it. Got it. Because I was like, I'm so lost, guys. Okay. So no, we cannot combine, that's our final answer for this. Let's do 12. Rewrite this. And then we're distributing twice.
I want to do this.
I know, it's alright. I'm going to take 8, multiply to everything in the second. So 8 times 8 minus the square root of 2. And then negative square root of 2 times everything in the second. So minus the square root of 2 times everything that was on the inside. And start to distribute. 8 times 8 would give us 64. 8 times negative 2 would give us negative 8 times the square root of 2. And then distribute to the second. Negative square root of 2 times 8 would be negative 8 times the square root of 2. Negative square root of 2 times negative square root of 2 would be positive square root of 2 times 2. And then simplify. 64. If you want to combine these two now, you can do that. And then the square root of 4 would be 2. Combining our like terms, 64 plus 2 would be 66. There was one last one I wanted to do that you guys have, but I don't have for whatever reason. Right about what? The answer. And you didn't even know how to do it. Look at that. Number 14 is what this is supposed to say, but I whited out the numbers and they aren't showing up very well. So this one. So after we do this, you'll have time to go back and practice the multiplication, the distributing / problems on the review. So let's distribute. Multiply the numbers on the outside, 3 and 5. And then the numbers on the inside, 2 and 10. And then for the second one, same thing, multiply the numbers on the outside. Same thing. And 2 and 6. So I don't know if you saw me do that, but you could have put plus 3 times negative 2 or minus 3 times just 2. Take out the negative since you already put it there. Either one of those will be fine. Multiplying everything, you'd have 15 times the square root of 20 minus 6 times the square root of 12. 20 can be broken down. The highest perfect square would be 4. The square root of 4 is 2. Twelve can be also broken down to the square root of 4. The square root of 4 is again 2. And then simplify. So 15 times 2 is 30. -6 times 2 is -12. Can we simplify this anymore? 3 and 5 cannot be broken down anymore, and we cannot combine them. Alright. So whatever problems you feel like you need to practice in the review, in those notes, work through those. If you feel like you're relatively good with all of that, work on the Khan Academy for this week and the Delta Math or radical operations if you haven't done that already. Use this time as review for anything you feel like you need.